Since the end of the Cold War, the drastically changed combat environment has favored combat ships that can carry carrier-based aircraft. For the US and French navies, a full-body aircraft carrier can provide flexible and timely force support almost anywhere in the world to deal with a variety of targets, a capability unmatched by any other weapon system of. This capability is particularly applicable to operations in littoral areas, where targets are numerous and varied and require multiple means to ensure their destruction. Since the late 1990s, the size of the US Navy has been greatly reduced, but the impact on the aircraft carrier fleet is much smaller than that of other types of warships. In any case, the enormous financial and technical challenges inherent in operating an aircraft carrier mean that navies of all but deep pockets remain unaffordable. In this context, many navies of second-tier countries are trying to obtain aircraft carriers by relatively cheap means. The trend dates back to the 1970s, when the advent of the short takeoff/vertical landing, STOFLO, capable Harriers seemed to offer a new, cheaper ticket to the aircraft carrier club. Short takeoff/vertical landing technology has not only allowed the navies of Spain, Italy, and Russia to deploy jet fighters at sea. Just as importantly, it also gives some fleets, notably the Royal Navy, an affordable option to deal with the increasing costs and complexities of maintaining legacy aircraft carriers. In practice, however, the number of countries developing new aircraft carrier capabilities is roughly equal to the number of countries abandoning carrier-based fixed-wing aircraft capabilities. In addition to the equally considerable cost, some countries have expressed doubts that the limited capabilities of the STOFLO aircraft will be commensurately cost-effective. However, this may be changing. The heavy use of merchant marine standards in warship designs, the advent of the more advanced F-35B Joint Strike Fighter, and the increasing wealth of many countries, especially in Asia, may make the deployment of fast jets more common on ships. Even for those nations that do not have the capability or ambition to equip fixed-wing carrier-based aircraft, the growing importance of the littoral area has led to a greater focus on the development of amphibious warfare capabilities. This increasingly requires the ability to support a significant number of helicopter missions. This has led to a number of development plans for amphibious assault ships, LHDs, with both helicopter capability and docking bays, by adopting a through-deck configuration that maximizes the total area of the flight deck. Another trend, led by the Royal Netherlands Navy, is the combination of amphibious operations and logistical support capabilities on a single multipurpose platform that resembles an extended amphibious transport dock, LPD. In the book Navy in the 21st Century, naval expert Conrad Waters focuses on introducing several representative aircraft carriers. They all have a high probability of being active in the vast oceans of the Eastern Hemisphere in the future, and become the challenges that our Navy needs to face. Important opponent: America. The U.S. Navy continues to lead the development of conventional catapult takeoff/arrested landing, CATOBAR, aircraft carriers, with 10 of the 12 aircraft carriers in the world using this technology in service with the U.S. Navy. These 10 ships are all 100,000-ton nuclear-powered Nimitz class, CVN-68, aircraft carriers. This class of aircraft carrier usually carries about 70 fighter jets and helicopters. Preliminary design work on the Nimitz class began in 1964, with the first ship being built under the Navy's plan mandate for FY 1967. Its basic design dates back to the conventionally powered Forrestal class of the 1950s, aircraft carrier with carrier-based aircraft. The Nimitz was commissioned in May 1975, and the George Bush X and final entered the Navy in May 2009. This class of ships has therefore become the warship model with the longest construction period among modern warships. During the course of the construction project, the design of the ships of this class has undergone various improvements. The USS Theodore Roosevelt, CVN-71, and subsequent carriers had better magazine protection, while the last two carriers featured bulbous bows, higher decks, and a modified island. Despite these improvements, it has become increasingly clear that the 50-year-old design is no longer up to date with current operational requirements. In particular, more precision strike weapons available mean that an alpha strike against a primary target does not really require an entire deck of fighter jets, as it did during the Cold War. What needs to be considered more now is the ability to deliver multiple strikes against different targets over a sustained period of time. In addition, the large number of personnel required by the Nimitz class, each aircraft carrier requires 3,200 core crew members, and legacy systems make it expensive to maintain its operation. On November 9, 2013, the U.S. Navy held a naming ceremony for the first new-generation nuclear-powered aircraft carrier USS Gerald R. The class is the result of a redesign of the Nimitz class aircraft carrier taking into account the requirements of 21st century naval aviation. Huntington Ingalls Industries. Gerald R. Ford class. The U.S. Navy embarks on commissioning the Gerald R. Ford class, CVN-78, aircraft carrier, a class of ships whose designs were derived from the CVX and CVN-21 development programs. Construction on the lead ship of the Gerald Ford class began in 2009, but preparations began several years ago. The shape of the hull of this class of ships is very similar to that of the previous class of aircraft carriers, but many innovative technologies are used to improve the sortie rate, SGR, and reduce operating costs. In order to achieve these goals, the most obvious visible change is the redesign of the flight deck layout to provide more deck space for flight and improve the operation process of carrier-based aircraft. These improvements included reducing the number of aircraft lifts from 4 to 3 and moving the smaller, stealthier islands to the rear. At the same time, the Gerald Ford class also redesigned the internal layout to improve the process of refueling and refilling the carrier-based aircraft. Equally important, though less visible, is the class's first use of two new technologies to improve the efficiency of catapult takeoffs and arresting landings. The two technologies are Electromagnetic Aircraft Launch System, EMLS, and Advanced Arresting Gear, AAG. The former replaces the traditional steam catapult and uses a linear induction motor to generate a moving magnetic field that pushes the shuttle that tows the aircraft to rapidly accelerate along the track until it reaches takeoff speed. The latter uses energy-absorbing water turbines to replace the less accurate hydraulic energy-absorbing cylinders of the existing Mk7 arresting system. Both systems offer greater reliability and accuracy than the previous generation systems they replace, further speeding up deck operations for carrier-based aircraft. There is also a particular benefit to adopting the new systems. They are better suited for a new generation of lightweight drones that may enter service within the lifespan of new aircraft carriers. The electric-driven electromagnetic catapult system also gets rid of the existing aircraft carriers' reliance on steam generators, making it possible to apply the catapult takeoff/arrested landing configuration on non-nuclear powered aircraft carriers. The schematic diagram of the design of the Gerald Ford. From the picture, we can see the improvements of this aircraft carrier compared with the previous Nimitz class. In addition to improving operational performance, these modifications will save $4 billion to $5 billion in operating costs over the carrier's lifetime. U.S. Navy. The enhanced flight deck design of the Ford-class aircraft carrier, as well as the use of an electromagnetic ejection system with excellent performance and advanced arresting devices, the ultimate goal is to maintain a dispatch rate of at least 160 sorties per day for a long period of time, and at the same time have the ability to dispatch up to 270 sorties within 24 hours. Sorties. Although some doubt that these goals can be achieved, compared with the Nimitz class's maximum sortie rate of 120/240 sorties, these goals are very telling. New systems installed on Gerald Ford class aircraft carriers, which also included a more advanced large radar, resulted in increased electrical demands on board. This need is met by two new Bechtel A1B nuclear reactors, which provide approximately 2.5 times the power generation capacity of previous aircraft carriers. In addition, a partitioned power distribution system has been redesigned on the Gerald Ford class aircraft carrier, which is lighter and more durable than the radial layout power distribution system of traditional old aircraft carriers. The U.S. Navy took this opportunity to also replace accommodation facilities such as galleys and laundry rooms on aircraft carriers with electrical systems, which help reduce the number of crew members. There are already two Ford-class aircraft carriers, the USS Gerald Ford and the USS John F. Kennedy, currently under construction, and preparations for a third are well underway. The first ship of this class entered service in 2017. The ship took longer to build and cost more than originally planned. Total expenditures have reached $12.9 billion, not including $4.7 billion in research and development costs for the entire class. This led to subsequent aircraft carrier design tweaks to reduce costs. However, the reduction of the 500 or so core staff and other efficiency improvements will significantly reduce operating costs. Over the planned 50-year lifetime, savings are expected to be $4 billion to $5 billion up to $100 million per year. India. Vikrant class. Although France and Brazil also have Tavar configuration aircraft carriers, no other country currently builds aircraft carriers in this configuration. All other aircraft carrier programs have incorporated some form of short takeoff technology since the end of the Cold War. The fighters carried by these aircraft carriers either use the short takeoff/vertical landing, STOFLO, type carrier-based aircraft similar to the Harrier, or use the short takeoff/arrested landing, STOVAR, configuration. The carrier-based aircraft of the STOVAR aircraft carrier takes off through its own power taxi, usually with the help of a ski jump springboard, and uses traditional arresting devices to land on the ship. India's first self-built Vikrant aircraft carrier adopts the Russian-style STOVAR configuration, which is a combination of ski deck short-distance takeoff and conventional arresting landing. This image was taken in June 2015, when the ship was last undocked after completing underwater operations during construction. There's still a lot of work to be done if the modified 2018 delivery is to be on track. Indian Navy. STOVAR technology originated in the Soviet Union at the end of the Cold War. The first to use this technology was the 1143.5/6 heavy aircraft carrier cruiser Admiral Kuznetsov, which entered service in January 1991. The Chinese Navy's Liaoning, formerly the Variag, a sister ship of the Admiral Kuznetsov, also uses this technology. China's domestic aircraft carrier under construction in Dalian may still use STOVAR technology. However, so far, the only newly built STOVAR aircraft carrier that has been launched after the Cold War is India's first domestic aircraft carrier Vikrant. The aircraft carrier was launched from India's Cochin Shipyard Limited on August 12, 2013. However, the Indian industry has not overcome its previous record of severe overdue deliveries. The delivery of the ship was delayed in 2022 after a long delay. The reason why India adopted the STOVAR configuration is also the result of being influenced by Russia. The STOVAR configuration avoids the complexity of ejection operations, but requires the aircraft to have a high enough thrust-to-weight ratio to complete takeoff without ejection assistance. India recently named the former Russian STOFLO aircraft carrier INS Vikramaditya after converting the former Russian STOFLO aircraft carrier Project 1143.4 Admiral Gorshkov into a STOVAR configuration, and equipped both aircraft carriers with MiG-29K attack fighter. Compared with short takeoff and vertical landing aircraft carriers, STOVAR aircraft carriers must be large enough to have sufficient takeoff distance, and also need an angled deck to ensure safe landing operations in the state of missing the arresting wire. Therefore, the full load displacement of the Vikrant exceeds 40,000 tons, and the total length of the flight deck is about 260 meters. Even so, one of the two off-axis aircraft takeoff points was set near the stern to help fully loaded aircraft take off safely. Although the STOVAR configuration of the Vikrant is obviously Russian style, the design of the aircraft carrier is also deeply influenced by Western design and technology. This is also a typical example of the mash-up approach adopted by many Indian warships in recent years. Among them, the Fincantieri company in Italy provided considerable design support, and the propulsion system mainly refers to the Cavour aircraft carrier of the Italian Navy. The radar and air defense systems incorporate Italian and Israeli technology. The ship will carry a total of 30 carrier-based aircraft, including about 12 MiG-29Ks. Imagination drawing of the Vikrant aircraft carrier in the completed state. The figure fully demonstrates the main design features of a STOVAR aircraft carrier. The aircraft takes off from two takeoff points via a ski jump ramp. The one near the stern allows the carrier-based aircraft to take off with maximum weight. Landing is via an angled deck with arresting gear installed. In addition, there are carrier-based aircraft parking sites and 6 helicopter takeoff and landing points on the deck. Photo courtesy of John Jordan. The delivery date of the Vikrant is significantly behind the original plan. According to reports, its construction cost has reached 7 times the original budget of 32.6 billion Indian rupees. As such, the desire to develop domestic industry through the construction of aircraft carriers has come at a high price. In addition, a question worth discussing is whether the STOVAR technology selected due to the historical relationship with Russia meets the long-term development needs of the Indian Navy. Considering the growing cooperation with the United States, India's second indigenous aircraft carrier may adopt the electromagnetic catapult system and advanced arresting device on the Gerald R class. UK. Queen Elizabeth class. We then move on to the more traditional short takeoff/vertical landing, STOFLO, configuration, the most important post-Cold War representative of the non-British Navy's Queen Elizabeth class, Queen Elizabeth, aircraft carrier MO belongs to. In the early 1990s, the United Kingdom began to develop a new aircraft carrier to replace the Invincible, STOFLO support aircraft carrier, and decided to build two. In the 1998 Strategic Defense Assessment Report, it was decided to build more aircraft carriers. However, various discussions have been carried out around the advantages and disadvantages of catapult takeoff and arrested landing, STOBAR, and stop-flow, etc., coupled with huge financial pressure. By the time the formal contract was signed in July 2008, a full 10 years had passed. Although the Queen Elizabeth-class aircraft carriers are in the stop-flow configuration, the final design can nominally be converted to other modes of takeoff and landing if required. However, after a detailed analysis of this technology option in the 2010 Strategic Defense and Security Review, it was found that the high cost of retrofitting would make the cost-effectiveness extremely low. However, the reconfigurable design still left a very deep impact on the design of this class of ships, including but not limited to allowing this class of ships to have a displacement of 65,000 tons second only to the U.S. Navy's nuclear-powered aircraft carrier. Sectional view of the Queen Elizabeth-class aircraft carrier. An interesting feature of it was two separate islands, the front island for navigation and the rear island for flight controls. The use of the integrated all-electric propulsion system allows the gas turbines of the aircraft carrier to be arranged directly under the ship island, which can shorten the length of the exhaust gas discharge pipeline and facilitate maintenance. The large elevator is capable of simultaneously lifting two F-35Bs or a Chinook with the rotors spread out. The hangar is not large compared to the overall size of the aircraft carrier, but it is also large enough to park most fighter jets. Aircraft carrier complex. In addition to having rich experience in the use of stop-flow aircraft carriers, another key factor for the British Army to decide to adopt this configuration for this class of aircraft carriers is that stop-flow aircraft have a higher dispatch rate. Compared with the advantages of lower aircraft procurement cost, longer range, and better interoperability with CATOBAR carrier-based aircraft of allies, the United States, brought by catapult takeoff and arrest landing aircraft carriers, this factor is more important. As important, the Queen Elizabeth-class carrier-based aircraft unit will consist of 36 fast jets and 4 early warning helicopters. The Air Force composed of these fighters will significantly improve the expeditionary strike capability of the British aircraft carrier. Although in the early plans, the single-day dispatch rate of this class of aircraft carrier should reach 150 sorties under the condition of carrying the above-mentioned carrier-based fleet. However, according to reports, this number has dropped to a maximum of 108 sorties in 24 hours, that is, each carrier-based aircraft dispatches 3 times in a single day, and when the aircraft carrier was officially ordered later, this number has dropped to 72 sorties per day, each twice a day. As with the U.S. Navy's Gerald R-class aircraft carriers, sortie requirements had a major impact on the overall design of the Queen Elizabeth class. For example, the innovative twin-island arrangement helps maximize the flight deck area. Pit stop refueling and ammunition storage helps speed up aircraft turnaround, while an automated cargo handling system quickly moves ammunition from magazines to hangars and flight decks. This also helps to significantly reduce the size of the crew. The ship's core crew number is only 680 people, which is comparable to the previous Invincible-class aircraft carriers. In terms of aircraft takeoff and landing, the stop-flow configuration has greater restrictions on aircraft operations than the traditional TOBAR configuration. The 280-meter-long flight deck and ski jump springboard of the Queen Elizabeth class allow the F-35B to take off with a full load of weapons. However, landing an aircraft that has not exhausted its payload remains problematic, especially in hot conditions where jet engines operate less efficiently. At present, the British Army is developing a ship taxiing vertical landing, SRVL, technology to relax the load limit of the ship. This technology uses a new auxiliary landing system, Bedford Array, a new object guided by the deck light array. However, in the absence of an angled deck, the stop-flow configuration can be riskier to land than the STOBAR configuration. In July 2014, Britain's first Queen Elizabeth-class aircraft carrier was launched from its construction dock. It is interesting to compare the ship as completed with the aircraft carrier Vikrant. Base systems. The huge cost of nuclear power means that the limited cost of the Queen Elizabeth-class aircraft carrier is unaffordable. Therefore, this aircraft carrier adopts the popular integrated all-electric propulsion, IFEP, power. The ship's gas turbines and diesel generators provide electricity for the electrical distribution network, as well as for the electric motors that drive the aircraft carrier, as well as for other electrical equipment needs from radar to interior lighting. However, the two aircraft carriers are not cheap. with a series of cost increases leading to a total budget of £6.2 billion, about $10 billion US. In fact, the entire project was at risk of being cancelled during construction. However, with the first aircraft carrier scheduled to begin sea trials at the end of 2016, the aircraft carrier has gained more approval. To some extent, the mission focus of this aircraft carrier has exceeded the original design. Under the guidance of the concept of carrier-enabled power projection, the Queen Elizabeth-class aircraft carrier can carry various types of carrier-based aircraft brigade to complete different tasks.